We're live. We're live. All right. For the millions of fans at home, we're doing the new problem set. I'll post a PDF on Classroom, or you can maybe arrange for a friend or a parent to pick it up, I guess. Anyway, we're not going to finish this before the break. We're probably going to get pretty far on it. And then when we come back from break, we'll do a quick refresher and finish it up and then move on. So let's get into some basic stuff here. So don't worry, if you're like, this is like too basic. Okay, it'll get more challenging. Okay, so an equation like that. There are a few steps to solving it, okay? What's the first step, guys?
Subtract the 2.
Subtract 2. Way back in the old days, they might have said, "Oh, you have to write this. You do not have to do this. You have to show your worth, but you don't have to write that. But do it if it helps you." Anyway, you subtract 2 from both sides. You got that? Okay. And then we divide both sides by 3. If it's not obvious to you what 48 divided by 3 is, that's okay. It is 16, but the way you could get that is you could go, well, what's 48? 48, can I break 48 into the sum of 2 numbers where one of them is obviously divisible by 3, like, for example, 30 and 18. So 30 and 18 divided by 3 would be 10 plus 6. So just throwing it out there. Part of these problems is hopefully going to help brush up your mental math skills a little bit. Okay, now what number squared makes 16?
4.
There's 2 answers. There's 4 and -4. Yeah, you can certainly write that as plus or minus 4. I like to write them as separate numbers just because it kind of highlights the fact that it's 2 different numbers. There are 2 different numbers that I could plug into this that would make the equation true. Okay. Okay. Let's do 1 or 2 more from this front page.
C.
Sure, C. 21 minus 2x squared equals 5. Okay. What do you guys think the first step should be? Yeah, subtract 21 from both sides. Someone in the other class said, they said they prefer to move that guy to this side. I'm like, yeah, sure, that works too. Remember, anything you do one side of the equation, you got to do it to the other side. And generally, you can do whatever you want as long as you do it consistently to both sides of the equation. So if we subtract 21 from this, we get -16. Then divide both sides by -2. We get 8. All right. So now, this raises an interesting question. Go way back to the ancient Greeks. There was some disagreement on this. They'd say, oh, if a square had an area of 8, say square feet. Not that they measured things in feet back then, but they did. There would have been some disagreement on what kind of number would that be. But anyway, we know nowadays it's an irrational number. Plus or minus the square root of 8. All right.
Just simplify it?
Yeah, we should simplify it. Just like in the same way that if you did a math problem or found a quantity and you found an answer like this, 6/8. You might go, okay, well, 6/8 is certainly a number. It's not like it's an invalid number, but it would certainly make sense to simplify it, that kind of idea. We're going to do the same thing here. How do you write the square root of 8? 2√2. So the process is you say, are there any perfect square, or really what you ask is, what's the largest perfect square that is a factor of 8? Well, it's 4. So you go, okay, 8 is 4 times 2. What's the square root of 4? 2. What's the square root of 2? √2. Does anyone have any questions on this last step here? Yeah.
Can you not just find the actual value of √8?
Well, so this is what we call the exact answer. So if we take a calculator and go, so let's say you're building something for whatever reason. I need the area of the square to be 8 square feet. It would make more sense in that situation to get a decimal approximation. So this is the simplified version of the number, but the square root of 8 is approximately 2.83. But this is like, the thing about irrational numbers is there's no way to write the decimal because the decimal goes on forever with no pattern, never repeats, never stops. And so what we call this is the decimal approximation. But we're focused on just the exact. Because nowadays, if we want a decimal approximation of this, a computer can get that very easily. So the purpose of learning these techniques is more not really to get the answer. It's more to understand how these operations work. Because if you understand how the operations work, then you can allow yourself to understand higher level math ideas. So if you're wondering, how come a computer can solve that very easily? So why study these techniques? But that's the reason, is the techniques give you deeper insight into how numbers and variables and how equations and expressions behave. And that kind of unlocks potential for learning more advanced, more interesting stuff. So should we do one more on this page, or should we just move on? Okay. Let's maybe briefly talk about H, because I need to clarify something. So, first clarification is, you're supposed to do all of these with no calculator. You should never need a calculator for any of this stuff, okay? Certainly, if you're really just curious, how big of a number is that? You want to punch into a calculator, there's no harm in that, but so try to avoid any step using a calculator. So H says you got 2x squared plus 18 equals 0. Okay, so first, maybe you can think about this. Why did I want to highlight this question? Why is this one special?
You can't have the square root of a negative number.
Yeah, exactly. So after 2 little steps of algebra, you should end up with x squared equals -9. Okay. Again, you might say, well, actually, there are numbers that work for this. They're called imaginary numbers. So is it wrong to say that the answer, you could say, for example, plus or minus 3i would be valid, but we're not going to deal with imaginary numbers in this class. Maybe at the very end of the year, if we had somehow extra time, we might discuss them a little bit. But the reason we don't discuss them is because when you take calculus 1, calculus 2, calculus 3, you're pretty much always just dealing with real numbers. And so we're just going to focus on those. So the question is there a real number that if you square it, you get -9? The answer is no. So you just say there is no. Now, of course, parenthetically, there is no real solution is the full answer to this question. There's no real number that works. Only an imaginary number would do the job. You guys okay with that? Does that make sense? Okay. Great. Let's look at we can just do 2a, I guess. 2a is a good place to start. So 1/2 of the cube of some number minus 7 equals 0. First step, You can add 7 to both sides, so this 1/2 x cubed would have to equal 7. Now what? Multiply. It's always, anytime there's a fraction as the coefficient of your x, you can just multiply by the reciprocal of that if you want to use the fancy words. So instead of 1/2, it's 2/1. Anyway, multiply both sides by 2. 2 times 1/2 is 1. So you end up with this. Okay. What number, if you cube it, gives you 14? There is an exact number.
Oh,
There is a number. Who's got it?
Roughly like 2.41.
True, approximately. That's approximately the number, yep. Very good, that's the answer. The answer is, how do you write that? The cube root of 14.
Is it plus or minus that?
What do you guys think? Is there one answer or two answers? There's only one. Because if you cube it, look, watch what happens if you cube a negative number. I'll cube the number 5. -5 cubed is -5 times -5 times -5. So I'd have positive 25 times -5. The key here is, look at my final answer. It's a negative value. So if you cube a negative, you get a negative, which means that this x can certainly not be a negative number. Does that make sense? There's only one answer. By the way, if you want to think graphically, you guys, does it make sense to you how I could kind of think about this question in this way? When does a x cubed function hit the line y equals 14? Maybe ask that question. We'll get into this in greater detail later, but something to start thinking about is, you can think about these questions graphically. How many times does a cube function hit a y value of 14? Well, only one time at a positive x value. Versus how many times does a parabola, oh, that's terrible, I missed. How many times does a parabola hit a certain y value? Twice, or maybe no times if it's a negative number. Okay. And yeah, like, so as a decimal, this number is, we know that 2 cubed is 8 and 3 cubed is 27. So if you wanted this number as a decimal approximation, it's somewhere between 2 and 3. 2 point something.
So for to the 4th power, it would be the parabola again, and you'd have negative power too.
Good point. Yeah. So if you're dealing with a 4th power, then yeah, then a negative or a positive to the 4th power makes a positive. So yeah, let's look at maybe C. C, if you've got x to the 4th over 2 minus 3 equals 0. Okay. By the way, is everyone okay with how this is the same as writing this?
Mhm.
Those are the same thing.
Yeah,
Yes.
I just realized that. When we had it right now.
I mean, I wouldn't say it's obvious. For younger students, that can be quite confusing. The idea that dividing a number by 2 is the same as multiplying it by 1/2. So if you didn't know that, then well, now you know. Anyway, add the 3 over, and then double both sides. Gives you x to the 4th equals 6. Okay. Now, again, April pointed out, well, yeah, if you have a 4th power, then, well, now x could be a negative number, right? Again, if you think about the pattern of, if you have x to the 4th power, and the even power, and you graph that, it looks kind of parabolic, and so that would tend to hit. If you ask how many times does that function hit a certain positive y value, it's going to be 2 spots. So how do I write this? 4th root of 6. That's how you write that number. Does that make sense? All right. let's do one of these ones that has, well, let's do 2D. 2D. 2D.
Dimensional.
Huh?
2 dimensional.
2 dimensions. You're back.
Yeah.
Oh no. That's okay. Did I give you one, James? Did I give-
Yeah.
So, looking at that problem, guys, does anyone see, it's 2D again, there's a trivial solution to that. Meaning there's an answer you can kind of get just by looking at it, without doing any calculation at all. Does anyone think they know what it is?
0.
Very good. Very good. Right, because if you made your x be 0, you would just have 0 plus 0. Right? 0 plus 0 is 0. So we already know, spoiler alert, 0 is one of the solutions. But is that the only solution? Could be, maybe it is, maybe it's not. What should I do here to maybe analyze this a little bit better?
Can you take out an X?
Yeah, let's take out an x. Very good. That's how we might find the 0. So if that didn't occur to you right off the bat, you would have found this by going, well, you have this kind of general idea when you're doing algebra, which is if you've got an expression set equal to 0, and every term in your expression has an x in it, then good rule of thumb is factor out as many x's as you can. Do you have any questions on that step there? No? Okey dokey. All right, so we just, okay, I've got a thing multiplied by that big thing, and it equals 0. So either that thing is 0, that's one possibility, or what's the other possibility?
Big old.
That this thing is 0. So, okay, well, 2/5 x cubed plus 4 could be the thing that's equaling 0. That could be the culprit. Right? Now, can we do this in one step? Or you guys? So I'm going to subtract the 4 from both sides, and then multiply the 4 by what? 5 halves. If doing that all in one step is, you're like, oh, that's gonna mess me up, that's okay, you can just write it out. But if you can do it in one step, that's great. Okay, so it's gonna be multiply both sides by 5/2. 5/2. So that times that makes 1. Here you get, so 4 divided by 2 is 2. 2 times 5 is 10. Okay, so now we get our answers. Don't forget that 0 answer. And then what's the other number? Yeah. You can write it as, it's more standard to write it as the negative cube root of 10 instead of the cube root of negative 10. Not to say that it's not wrong to say the cube root of negative 10, but just this is the more standard way of writing that number. Having the negative outside the radical. Okay. Are there any questions on, these guys kind of all have sort of a central theme of, oh, by the way, I want to point out something real quick. Someone in the other class said that for this, the way they were thinking about it was they thought, well, what if I just divided everything in the equation by x as my first step, like this? Makes sense? Is that legal? Yeah, as long as you are very careful. As long as you look at that and say, I have identified 0 as a solution, and I've jotted it down. Then you say, well, if x is not 0, then I can divide everything by that quantity and get this equation. And of course, this equation just leads you to that. So you certainly can divide everything by x, just be really careful that you're not like, because you can see, you kind of lose that 0 solution if you divide everything by x. So you end up losing that. Okay, let's look at 3. We'll do one of them. I kind of gave away the fun. Big spoiler here. It says solve by factoring. No.
No.
Factoring. It came factoring. Okay. Well, maybe you guys are rusty on this technique. I don't know. This first question says, what number, can you come up with a number that if you square it and subtract 16, it's the same as multiplying it by 6? So let's see. Can we, now there's a big hint here. It says solve it by factoring.
If I can go.
Now, here's a wrong approach. Tell me if you don't see why this is wrong. Not that it's unreasonable. I mean, if you took this as your first step, I'd say I can see why you did that. It makes sense why you would take that approach, but is that going to be fruitful?
No.
Not really, because, I mean, sure, the left side looks maybe a little bit nicer to deal with, perhaps, but I still have this pesky 6x over here. So I wouldn't say that I've made the question any simpler. So what's the actual key to solving this? Very good. So the general idea is if you're dealing with an equation and you've got a quadratic term, like an x squared term, and a constant term, and a linear term, meaning a term with just a single like x in it, get everything on one side of the equation so that it reads like this. Does that make sense? All right, now we go, okay, we're tortured with this mercilessly in Algebra 1. The pain. Right, Nikita?
Of course, the
The pain. Okay, so can we factor it?
No.
Yes, we can. Maria. We can factor it out. Okay, what two numbers add up? -6 multiplied by -16. Well, -8 and +2. So that's going to tell me my two answers. What x value would make this thing equal to 0? +8, of course. And what x value would make this thing equal to 0? Well, -2, of course. So there you go. There were two answers to that question. Certainly wouldn't hurt to plug them back in to check our answer, just to make sure. 8 squared minus 16. Is that the same as 8 times 6? Yeah, they're both 48. Plug in -2. -2 squared minus 16 is the same as 6 times -2. They're both -12. We should probably do one last one. Is this torturous enough for you?
I see a word problem at the bottom of this page.
Yeah. Let's do another Bob problem. Bob has a lot of interesting things happening to him.
Bob?
Yeah, see, it's Bob again.
Yeah, Bob's a great man. Okay, well, I just need to make sure no one is. How about this? Look at 3D. See if you can solve that relatively efficiently. We'll go over a solution, and then we can end by talking about number 4. plus 2 plus 2.
Oh.
So I hope that was your first step to go, well, I don't really want to have this parenthetical expression, so let's distribute the x and get rid of those parentheses. And then what's your next step here? Not yet.
And a
You're gonna
zero.
bring that 3 over first. And now you go, okay, it says solve by factoring, so hopefully there's not like a typo, hopefully actually is factorable. Do you guys know what it means if this number is negative? It means that, yeah, your two terms, one's gonna have a minus and one's gonna have a plus. That's the only way that this term will be negative. And we also know that because this term is positive, that, I don't know, I guess, how do I say this? Maybe the weight of the positive term is bigger.
But your plot, like, when you have like your x plus number, the plus number can be bigger than the negative number.
I hesitate to say that just because this 5 is gonna kind of weight them in a weird way, but you guys might, depending on how much you were made to suffer back in Algebra 1, sometimes they give you these problems where this coefficient is like, 24, this one's like 30, you can check like a million combinations. We're gonna keep them pretty simple. 5 and 3 are both prime. They're good exercises because they, you got to know how to factor. Anyway, so if this is 5, there's only one possibility. Thankfully, it's a 5 and a 1. Right? If this number was a 6, you would have to check 6 and 1, 3 and 2. You'd have to check both combinations. Prime numbers are our friends for this. So 5 and 1. Now these numbers there's only one possibility. It's either a 1 and a 3 or a 3 and a 1. Right?
That's -3.
Now, how does this work out? Well, it has to be a positive 1 there and a negative 3 here. And that's because if I re-multiplied this out, I'd have 5x times x, 5x squared, 5x times 1, negative 3 times x. Notice what do those guys do?
Yeah.
That makes 2x. And then negative 3 times 1. Does that make sense, what I just did? So it's not quite as simple. When you have a lead coefficient like this, it makes it a little bit more complicated. You have to pick a pair of numbers where 5 times this plus this times 1 makes 2. Anyway, what solution does this guy contribute? Negative 1. How about this guy? 3 fifths. So, anyway, looking at this original one, getting negative 1 in your head is doable. I mean, it certainly didn't occur to me. I didn't. Sometimes they have simple solutions that pop out to you. This one, I don't know, maybe that occurred to you. If 3/5 occurred to you just by looking at that, then thumbs up. You can. They did that back in elementary school. The teacher would say, "Pat yourself on the back." People would like literally like to.
It's so uncomfortable.
Oh, I actually got pretty good at it.
You get a cross.
Can you reach it, Mason, or are you too yoked? My muscles are too big. I can't reach my back. All right, guys. So we can end class with just a brief discussion of this word problem. Bob claims. Now, Bob is a charlatan sometimes. You have to be skeptical of Bob. Sometimes he makes claims that can't be substantiated.
Bob drives weird too. We shouldn't
Yes.
trust him with anything.
Yeah, from prison. He claims that he has a rectangular piece of paper that, if folded in half, produces a rectangle that is proportional to the original rectangle, i.e. its sides are in the same ratio. Is this possible? Is Bob full of it? Now, gives us a hint. I'll give you a big hint. Bob is not lying. This is possible. So the question is, what's the ratio?
Same.
You could try that. That's a good start. You'd say, what would happen if your first piece of paper was a square? What if they was the same length and width? So for example, what if you had a 1 by 1, right? What if you had a 1 by 1 piece of paper? Well, what's going to happen when you fold that in half, though?
It's gonna be 1/2, but
You'd have 1/2 by 1. Now, are those in the same ratio? No. Okay. Back in the old days, I taught a class where we would try to figure this out through guess and check. And we'd see who could get the closest through guess and check. And it was interesting to see sometimes how close someone could get with guess and check. I didn't give them the hint of making the one side be 1, but they would come up with ideas like, they'd go, well, I don't know, what if I did, I don't know, say 10 by 6. So smaller, if those were inches, that's smaller than a normal piece of paper, right? Do you guys know what a regular piece of paper is?
12, yeah.
8.5 by 11 is the standard American sheet of lettered paper. Anyway, so they would take this, they would cut it in, then they cut it in half. You go, okay, well, I just folded it in half, so now it's 5 by 6.
I'm getting way better. I'm sorry for distracting.
So the question would be, is the ratio of long side to short side on this rectangle the same as the ratio of long side to short side on this rectangle? Let's test it out. Is 10 over 6 the same as 6 over 5? And you can, if you cross multiply, you can see we didn't do that good of a job in this case. So anyway, so then what you might do is you might go, again, this was this. What if you did 6 by 8? Oh, thanks, Melissa, you're right. Now again, is the ratio of 8 to 6 the same as the ratio of 6 to 4? Again, not the same, but did we do a better job?
Yeah.
Yeah, that's a much better, much closer, okay, proportionally. So anyway. All right, let's do it the big brain way. Okay. That was more of a pre-algebra class, so it was like they could get some of the answers they came up with were remarkably close through guess and check. The problem is you can't really get it through guess and check unless your guess and check thinking is at like a higher level. Does anyone have a guess that they think might be correct, even maybe with that hint? A ratio that might do this? Anybody guess?
No.
Okay.
1.
All right, let's use the hint then. The hint. Let the short side of the paper be 1.
1 by 1.
Okay. So let the short side be 1. And then let the long side be X. Make sense? Now, what should we do? Let's fold it in half. Now our piece of paper looks like this. How long is that? How long is that? Half of X. Okay. Now what equation could I write about proportions, that kind of like the ones we were just writing a few minutes ago? So 1 over x. So the ratio of short, this is long. We're going to compare the short to the long ratio. Short divided by long on this rectangle should be equal to, how do I write the short divided by long on this guy?
5x over.
This is where you gotta be a little careful. This is now the short side.
Oh, yeah, so two.
This is the long,
X.
this is the short.
0.5x.
It's just gonna be x.
So half of x divided by 1, like that. Do you guys understand that?
Yeah.
What's half of x divided by 1?
Half of x.
So I'm just writing it like this. 1 over x equals x over 2. How do we solve that? Basically either think of it as cross multiplication, or I'm multiplying both sides by x and both sides by 2. Are there any questions I'm getting from this to this? Make sense? Okay, so what's the answer then? Turns out, how long was this side?
Square root.
Yeah, well, we're kind of restricted to it's got to be a positive, so we'll just take the positive number. So it turns out that the ratio is a root 2 to 1 ratio. And that's actually the standard English piece of paper. I think it's called A2, is basically in that ratio. So if you fold it in half, it's the same proportions.
That's gnarly.
Gnarly.
I don't